Hello students, welcome back. In today's video, we are looking at how to handle unfamiliar questions. It's easy to panic when you see a complicated reaction in the exam, but I'll show you why you don't have to. We will walk through the solution together step by step so that you will learn how to solve the question and get those marks in the exam. So let's get started. Whenever you see a reaction, first identify what are the functional groups present in the molecule. Say in this case, there is a ketone and there is a cyclopropane molecule. So now what should strike your mind the moment you see this is that the cyclopropane molecules are not quite stable because of the angle strain. That you have to keep in your mind. And also you see there is a halogen. That means what? There might be elimination in the molecule because the moment you look at the options, you see there is no bromine. So there has to be somewhere elimination, reaction, or maybe substitution. We don't know. So let's analyze that. Now that you have understood what are the functional groups present in the molecule, and there is a probability of opening up the ring because it is a cyclopropanone, right? So keeping these things in mind, understand what is this reagent. Here, sodium methoxide is given in methanol. Now, what are the properties of this sodium methoxide? It's going to form methoxide ion. Sodium is of no use, so we can ignore that part here. So the methoxide can act as a nucleophile or as a base. Let's say if it acts as a base, what it does, it will abstract the proton and form the carbanion. Because the carbanion can be stabilized by the ketone, right? Because of the resonance. That is quite understandable. Now, even if it is stabilized by resonance, so what next, right? First of all, the cyclopropane ring itself is having some strain in the molecule. Why it should get stabilized by resonance? So from this concept, you have to conclude that, yeah, methoxide cannot act as a base here. It is trying to open up the ring. That's why you see in option C and D, they are open chain molecules. So this approach is wrong. Now, let's try to make it as a nucleophile. Then what might happen? As I told earlier, the ring is already strained. When we open up the ring, right, then it will have some stability. How do you open up? Now, that is the question. The ketone carbon is electron deficient. Because of that, the methoxide will attack over here. One thing. The second thing is when it attacks, the ring has to open. When the ring opens, it will gain stability. So the approach is in right path. Again, the question is where you have to break the carbon-carbon bond, because either this carbon-carbon bond should break or this carbon-carbon bond should break. That's the reason why they have given these substituents, phenyl and methyl. Phenyl is nothing but C6H5. So if you want, you can elaborate that. So definitely it's going to help you. If there is anion formation on the carbon here, then it will withdraw electrons so that it will stabilize it. Let me repeat this. When the methoxide attacks this carbonyl carbon, if the ring opens here, the carbon here will become carbanion, which in turn is stabilized by benzene. Many students assume that, oh, okay, there is a methyl, so it donates electron. So that means it destabilizes. No, that doesn't happen because the benzene, which is exhibiting resonance, predominates over inductive effect. That you have to keep in mind. Resonance always predominates over inductive effect. So remember that. That's why the bond will break here. And there is one more reason which I am going to explain. But let's assume we don't know what is the reason. Okay. So let's write down what will be the product. How to write? Very easy. So there is a carbon attached to benzene, nothing but phenyl, which in turn attached to methyl. You write that as it is. Now, this is where the carbanion is formed. What about the other carbon. See here, this is attached to one more carbon here like this, right? Which in turn attached to bromine, right? Like this, okay? But that is in turn attached to what? CO. And then it is becoming ester, OME. Now, how many carbons should be there here? 1, 2, 3. Let's do that. 1, 2, 3. Yeah, so far whatever we have written is correct, right? And then you see, this is being stabilized by resonance. That is the reason. There is a bromine on the second carbon. So what might happen? Finally, in order to get stabilized, it will undergo elimination like this, because there is a good leaving group. Bromine, iodine, right? All these are considered as good leaving groups because it's leaving the molecule. If you want, you can just write it as phenyl, no problem now. So its function is over now, right? So phenyl is there is a carbon attached to methyl. So here we are getting the double bond because the bromine is gone. So this is a carbon which is attached to the ester like this. So this is the final product. So just verify where we have this. Obviously not A and B. We have already eliminated this, right? Let's check for C. There is an ester which is alpha beta unsaturated. So this is alpha beta unsaturated. And here we have phenyl and methyl. Phenyl and methyl. So that means what? The final answer is option C. It cannot be D. There is no shift of methyl. So methyl shift happens when there is a carbocation formation. Here there is a carbanion formation. No shift of methyl phenyl in this case. Hence, this cannot be the answer. Many students think that, ma'am, you have taken 7 minutes to solve this question, but we will not have so much time in the exam. I absolutely agree with you. But when you practice such examples more and more in the exam, you can solve such questions under 2 minutes, which is actually great to score marks from such questions as it is moderate to complicate level. I hope I made this concept and how to approach questions clear to you. And if you still have any questions, you can comment your doubts in the comment section. And don't forget to solve a question based on the concept we have discussed here. Thanks for watching video. Until next time.